Hello everyone. Today we will solve lead code number 2571, and the question says that minimize operations to reduce an integer zero. Means you have given one integer n, positive integer n, and you can do uh, either uh, either of these two operations. Like you can add 2 to the power I, or you can subtract 2 to the power I from n and return the minimum number of operations to make n equal to 0. And maximum value of n could be 10 to the power 5. Um, Let me open the whiteboard. So basically you have given n, and we need to convert this n to 0. For example, we have like n value equal to 5. Okay, and we need to convert this n 5 to 0 with the minimum number of operations, and in each operations either I can add or subtract 2 raised to power I. So we can think towards like bitwise operations, and in the bitwise operations, like what is the way we look at number that changes. For example, this any decimal number d, uh, it stores in terms of the binary format, right? And if the device is 32-bit or 64-bit, and based on that binary representations get stored into the device. So this D can have a bunch of zeros and one uh, into its binary representation. So if somehow, suppose if it is 32-bit, then suppose 00, we will have like this up to 32 length. Okay. So the question is like uh, in minimum number of operations, convert all ones to 0. That's the like overall point. So how can we convert this all ones to 0? Like we can use either to add or subtract 2 raised to power I. So let's break this into smaller piece. Suppose I have 0 and 1 in this format. In this case, if I subtract with 1, which is 2 raised to power 0, then I think we will able to convert this into 0, right? And if I have a number in this format 1111, and if I add 1, then all will be 0 0 0 0 and then 1, right? So here I'm able to convert more ones to 0 with 1 when I have 1 uh, in the neighbors of the rightmost one, right? So in bitwise operator, basically we perform the operations from right to left. Though in the decimal number, we perform or iterate the numbers from left to right. So the approach would be like first identify what value we have at the rightmost place. If it is 1, then we need to convert this 1 to 0. If it is 0, then we can do the right shift, basically shift this whole number by 1 bit towards the right side. So basically it's a discard this 0. That we can do using right shift operators, and we can keep doing until all the ones converts to 0, right? So that's the intuition and approach I'm thinking to take. Let's code this. So let's suppose I have this is the 0 result that I'm planning to store, uh, and then iterate this n until n converts to 0, and check if the rightmost digit of this n is 1 or not. So to check what I can use bit masking of 1. If n and 1 equal to 1, it means it has the its rightmost digit is 1. How it is? So I'll quickly show here. Suppose I have some number. bitwise 1 1 1. And if I do the AND operation with 1, the bitwise value of the 1 will be like this, all 0 and 1. And if I do the AND operation, then it will be 1 and all remaining will be 0. So after doing the AND operation with 1 to the given number n, if the value is 1, it means the rightmost digit of the n have value 1, right? So if n and 1 AND operator with 1 equal to 1 means the rightmost digit have 1. We need to perform some operation. Okay. If not, if it is 0, then we will do the right shift operator. Basically it's 0, then we will just right shift. So we will right shift by 1. Okay. If the rightmost digit have 1, then we need to do some operation, either addition or subtraction, and both will requires one operation. So I will increase the result by 1. Now which operation to perform? So for example, if number is like, suppose this is my rightmost digit, okay, and some number we have here, and now either I want to add or subtract with 1, right? So if this number is 0, then I will subtract. If this number is 1, then I will add. Then how to test it whether this number is 0 or 1? So if I bit mask with 2, uh, bit value of the 2 is 1 0, and then this side will be 0, right? So 1 and 0. If I do the AND operation with 2 and everything is 0, it means this value is, it means this value is 0, right? So if n and 2, this is 2 is bit mask here, um, equal to equal to 0. If it is 0 means I have the 0, then I will subtract 1 from n, else I will add 1 to n. Okay. And at the end I will return the result. Okay. So here basically I'll be iterating till n becomes 0, and then based on the rightmost digit whether it's 1 or not, I will perform operation. If it is 0, then I'll do the right shift, and then if it is 1, then either subtract or add. Okay. So yeah, that's it. I think let's run it. Yeah, it's passing. Let's submit. Yeah, it passed all the test cases. Okay. Let's see the time complexity. So max value of n could be 2 raised 10 to the power 5, right? Which is, if you convert into 2 to the power 2 raised power, then it becomes 2 raised 22. So maximum n can have 22 bits. These bits can be 1 or 0. In worst case, suppose all are 1, then we may need to iterate on. So the time complexity would be like t would be 20. I mean, this is constant. At most 20 iteration it can make. Space, I'm not using any extra variable other than this result. So this is also O1. Yeah, I think that's it. Thank you.